All right, you guys are working on your warm-ups, or you might already be done with them. Let's check them.
Thank you.
All right, so graphing linear equations. Your vocab word, a linear equation is what? Josh?
It's an equation whose graph is in a line.
It's an equation whose graph is a line. So when you hear that word, a linear equation, automatically think to yourself, I can draw this in a line on a graph. Sam Mendes. The points on the line are solutions to that equation, meaning anywhere along that line, I can plug those into my linear equation and it would still be true. Okay? You can use a graph to show the solutions of a linear equation. The graph below represents, here's your linear equation, y equals x plus 1. Get used to this format, y equals stuff, because that's all linear equations are going to look like. Okay? So you can see here they plugged in some points here, -1, 0, 0, 1, and 2, 3. If you plug in the x value, it comes out with the y value, input and output. So the x value for this first one is -1. They plugged it in here. -1 plus 1 is 0. So you can see the y value was 0. We have done this. I'm waking your brains up. It's been a while. Okay? So let's go to our first example. Write this in your journals. Okay, you're going to want to sketch a little graph. Do I have graph paper back there? Let me pause this. I think I have graph paper. You need to get some graph paper. All right, so we're going to graph this equation. Y equals -2x plus 1. So you get your graph. We're going to make a table of values first, because the way you graph, and I'm going to show you the easier way to do this that I hoped they would show you, but I'm going to show you anyways. So you're going to make this table in your journals first. And then I'll shorten this so you only have to do this the hard way once. And then I'll show you the easier way. Okay? This is the long way. It's not hard. It's just, you have to make this table that you see right here. Because we're going to find the solutions to this linear equation so we can sketch it on the graph. So we're going to find several points. So I'll give you just a second to sketch that.
Yes, so no.
Okay, so what we're going to do is choose your x values. So you get to pick these. Now, for this example, we're going to put specific ones. I recommend you always choose a negative x, 0, and a positive x. After that, it doesn't really matter, because that's going to give you a point in a quadrant 3, usually, the origin, and then quadrant 1. Okay, so put these down for your x values. And we're going to solve for the y value. So you're going to plug in this 1 where the x value is here. See how they wrote it in here? And then we solve this. What is -2 times -1?
-2.
Negative times a negative is a?
Positive.
+2. Plus 1 is? 3. So your y value is 3. So then write this as a coordinate. X being -1, y being 3. Okay, so all we did was solve for a... Oh, the word left me. Coordinate. Thank you. So this is a coordinate point on a graph. Okay, let's solve for the second x. So we're going to plug that in again, where the x goes. What is -2 times 0? 0 plus 1 is 1, so your y value is 1. So my coordinate is 0, 1, because my x value is 0, my y value is 1, xy. All right, the last one, 2. Again, we plug it in. What is 2 times -2? -4 plus 1, -3. So we get our coordinate as 2, -3. So we have 3 solutions here. So we're going to graph these 3 solutions on your coordinate plane. Okay, so we're going to plot them. The first one, x and y, we're going to go to the left 1 and up 3. 1, 2, 3. Put a dot. And make noise, evidently. So -1, 3.
Yes.
So I start at the origin, go back 1, up 3.
Yes.
Follow?
Yes.
Excellent. The next one, 0, 2. So I start at 0, I don't go anywhere. And then I go up 1. Put a dot. My last value is 2, 3, so I go to the right 2, and then down 3, put another dot. And then since this is a linear equation, you need to draw the line. It's the name. If you are OCD and want it super straight line, use a straight edge like a ruler. If you don't really care, I don't really care. Just connect them as best as possible. I mean, as long as it's not like super squiggly. It's supposed to be a line. It's a squiggly line. Okay, any questions on how we did this?
Questions?
Do we have to write the
Table? Oh, do you have to write the coordinates? I would for the example, but then in your homework, no. Okay, now do you want me to show you the faster way to do this? All right, let me get my whiteboard. Now, remember my whiteboard? It's a little sketch with my sketching with a mouse. But we make it work.
It's fine. Miss Gianna wrote it.
Miss Gianna had
Miss
amazing
Gianna's-
handwriting.
It was.
Whiteboard
It was
writing
literally
is
this.
terrible. I mean,
Enough.
Come on, whiteboard. Come on. Shh. Hey, don't worry about it. Relax, relax. Here we go. Shh. All right, let me go back. This was y equals, put this in your journals,
Oh,
negative 2x plus 1. This is my fantastic coordinate plane. 1, 2, 3, 4, 5. Don't judge me. Man, it is.
it's gonna blow up.
It's working hard.
Oh.
yes.
All right. So, I hope you guys have seen this before, but I can't guarantee it, but I'm going to talk about it. So, this equation here is written in a specific format that is called y equals mx plus b. Have you guys seen this before?
Yeah.
That disturbs me. You've seen it. You've seen it. So, y equals mx plus b. The m here stands for slope. Write this down. Okay? And your slope equals rise over run. Okay, and then the b value right here, this is called your y-intercept. So yes, we are labeling parts of this equation so you understand it. Okay, so slope is m, which stands for rise over run. The b is your y-intercept. This is algebra, guys. This is high school. You guys, this will make it easier for you when you get to Algebra 1 in high school, I promise. All right, so if you understand y equals mx plus b, this is an equation you will see forever and forever all the way through college. Memorize this. Trust me on this.
Bless you.
Okay. So when I'm looking at this equation, m being the slope, the m in this one is right here, right? Negative 2. So I can say m equals negative 2, right? Whole numbers are over what if I wanted to make this a fraction?
1.
Very good. Okay, and then this y-intercept is b. What is my b here?
1.
A positive 1. Once you have these two values right here, you can graph it. So once you understand this, I don't even have to write all this. I can look at this original equation and graph this. Let me show you. Bigger dot. I don't know. 4? Let's do 6. So on this graph, which line is the y line, which is the x line?
Y.
That's not an answer. This is the x line. This is the y line. So the y-intercept is at the point on the y line where the line we're drawing crosses it. It intercepts the y line. Does that make sense? So my y-intercept is 1. So where is 1 on this line? Up 1, right?
Yeah.
Right there. There there's my dot. So that's my first dot, is that y-intercept. So draw a dot there. You can just sketch this if you want to. You don't have to make it look all. Or you don't even have to sketch this because you can just see. It's going to be the exact same line you just drew, just so you know. So my y-intercept, put a dot. Now I need only one other point on this graph in order to draw a line, right? Because you just need 2 dots to connect a line. So now I'm going to look at my slope, which is rise over run. The rise being whether we go up or down. The run being whether we go left or right. The really cool thing about this is you're always, always, always going to go to the right. Your run is always to the right. So, if my slope is negative 2 over 1, I start at 0, 0. If it's a negative, which way do you think I'm going? Down. So I'm going to go down 2 over 1. So here's my second point. Okay. So now I have 2 points. Oh, snap. I can do it. I can do it. I can do it. Yeah.
It's very
As good as it gets with drawing with a mouse. That line is exactly the same line that you did in the first example. You see, once you understand what you're looking at with the y equals mx plus b equation, you literally just need this equation right here in order to sketch a line. You don't have to do a table and all that mess. Does that make sense?
Yes.
Any questions on this? This is super important that you understand this. Yes. You can say, I don't really get this, explain it a little more, and I will.
So how is it the same though? Because isn't it like
So the points aren't necessarily on the same points, but if you look at where they go through on the line, it's an identical line. This point is, we did sketch this one. You guys sketched this one as one of your points in the first example, right? And then your next point was not here, but it was a little bit further down this line, I think. Sydney.
what happened to the third dot that we had in the old one?
So the reason we had 3 dots in our example is they always recommend you, when you're making a table, you use 3 x's and solve for the y's. Look up your example. What was the third dot point?
Negative 1, 3.
So I went back 1 and I go up 3. If I could sketch correctly, it would end up on this line right here. The reason it's not perfect is because my sketching. But here's the 1, 1, 2, 3. See how it's right there? Mm-hmm. Yours would be correct because yours is a printout. My sketch is sketch. Good question. But to draw a line, you really only need 2 points. Good question.
All you do is just put it over, put the slope as a fraction,
Yep. Make the slope into a fraction, and then you'll have your rise over run. So you always start with the y-intercept. You draw that you plot that first. So ours was at 1, so we put it here. Once you have the y-intercept, then you look at the slope. If it's a whole number, you just put it over the number 1. If this was a positive 2, we would have started at the y-intercept, gone up 2 over 1, and put it that way, and then our line would be going in this direction. But it's a negative 2, so we went down 2 and over 1. So that's why the line's going this direction. Okay, this is called a negative slope because the line is going negative. If it's going the other direction, if it were going this way, it'd be a positive slope. All right? We'll go over this more, guys. So I just wanted to show you that you're not going to have to do tables forever because tables are tedious. All right. Let's work on your try-its, 1 through 3. Yes. Okay, on number 1, and yes, Sydney has seen this before because she used to watch me teach the 8th graders last year. So y equals 3x. If there's not an ending here plus anything, you always assume plus 0. So then your y-intercept would be 0. Then you just look at the 3. Okay, 3, and it's over 1, so I go up 3 over 1. Now I have 2 points on a line. Yeah, apologies. I didn't tell you that because they didn't give me an example with the 0 yet. So there you go. So that should help you. All right, I'll give you a couple more minutes. I know it's been a while, and this is a lot to start your brain on. So here's number 2. What is my y-intercept?
I.
Negative.
Negative 1, so I'm going to go to negative 1, put a dot. So there's your first. Yeah, always do the y-intercept first. Always, always, always. Y-intercept first. Write that in your journal. Y-intercept first. That way when you go back to do your homework, you're like, what am I doing? Y-intercept first. Okay, then your second thing is to look at the slope. The slope is what? Negative 2. If I were to make that a fraction, it'd be negative 2 over 1. So I start at your y-intercept that you just graphed. And then I'm going to go which way? Up or down? Down. 1, 2. To the right 1, second dot. So write that next. Yeah, when you graph the slope, you start at the y-intercept where you graphed that dot, and you count down and over. Not at the origin. You start at the y-intercept. Does that help? So from there, that's the word you need. From the y-intercept, sketch the slope. Does that help? That's better phrasing. From the y-intercept, I went down 2 to the right 1, and there's my second point. Okay, you want to do number 3 together? And then I'm going to make you do number 4. It's probably just whether I got it or you don't get it. You're welcome. All right. Shh. All right, well, you're going to try. All right, so what is my y-intercept? So I'm going to go, 7th grade. I'm going to go to 2, put a dot. What is my slope? It's already a fraction. Negative 1, 2, right? So from the y-intercept, I go down how many? Down 1, and then to the right, 2. Boom.
Wait, how would you know?
Because it's rise over run. So the top number is whether you go up or down. When it's a negative number, the negative applies to the top.
So as a fraction, it'd be y over x.
Yes, if you want to think of it that way. It's actually, let me show you. There's a more proper way. That was an excellent question. So, let me write this down for you. I would write this in your journals as an additional help. Okay, we have rise over run for slop. Aw, slop. Slope. I know, it's now forever going to be called slop. I know you guys. Okay, rise over run. This means the rise is actually, this might confuse you a little, but don't let it. The change in y over the change in x.
Yes.
Because eventually they're going to get to the point where they don't tell you what the slope is, and you have to solve the slope before you can graph it. And this is how you solve for slope. They'll give you 2 points on a graph and ask you what the slope is. So it is y over x. So it's the change in y over the change in x. The triangle means change in. Just so you're aware. You will see this again, guys. Yes, Elena. So that's telling me if I had a graph, say I have a point over here and a point over here. It wants you to, it's asking you, what is the slope of this, terribly drawn line? Okay? So, I don't know the slope. They didn't tell me the slope. You'd have to calculate the slope. So the way to calculate the slope is, let's pretend this is negative 2, 4? Sure, why not? And we'll pretend this one is 3, negative 3. Okay? These are your 2 coordinates on this graph. This is your x values. This is your y values. Everybody knows that, yes? X and y. So to solve for the slope here, 2 ways you could do this. You could look at this point and count it. 1, 2, 3, 4, 1, 2, 3, whatever it is. Or you could mathematically solve it by saying y2 and just pick one. Make this y2, make this y1. So we have 4 minus a negative 3. 4 minus a negative 3. So that would be 7. 4 minus a negative 3, this becomes plus. Okay, and then the other one is, and whichever one you made the 2, you make the other one the 2. So negative 2 minus 3. So that would be negative 5. Okay, so this would be your slope. Like you had the negative 1/2, you would have solved and you would have got negative 1/2 there. I'm going really in depth here, you guys. You don't have to know all this yet. You will get to this. So don't have to stress about this. But if I were to look at this, if I counted this, I go down 7 over 5. Yeah, you'll see it makes a triangle. In math, everything's built around a triangle. You'll see them so many times. All right? Again, this is like a little more in depth than the lesson is going to require of you. So this is like bonus knowledge. But it will help you. All right. So then everybody should have 1, 2, and 3 done. I hope you answered. Oh, I need to check it. I hope you answered your other. Let me chat for a second. All right. So we're going to discuss graphing horizontal and vertical lines. So this can get a little tricky here. So you got to train your brain to think it's backwards. I will explain. So the graph, I will explain. The graph of y equals b is a horizontal line passing through this point. So if I just have, say, y equals 1, you're going to go on the y line and put a dot at 1 and then sketch a horizontal line. Your brain wants you to say it's a vertical line because I'm on the y line. Right? Does that make sense? But you're on the y line, which means the dot goes there and the line goes horizontal. Okay? So if I have the x equals a number, then it's going to be a vertical line because I say x equals 1. I'm going to go over 1 and put a dot. And then I draw a vertical line on that 1. We're going to do this. It'll make a little more sense. This gets a little convoluted here. Okay? So everybody got this in your journals? Question?
Oh, wait, I was just saying, maybe like something to remember is like, if it's y and the x is like on top of it, then if it's x, then y is on top of the x.
No, because it's just looking at where the 0 is. So when you have y equals a number, then your 0 for the x value makes this a horizontal line. And then in this case, the 0 for the y value makes this a vertical line. So that's an easier way to think of that. All right, let's go do an example. So you need another little graph. Actually, you need 2 of them. Or if you want to use one graph and graph it in 2 different colors, you could do that.
That's complicated. I can't make a pencil 2 different colors.
Yeah, you'd have to get a colored pencil or a highlighter and highlight the lines. I know. Okay, here we go. So we're going to graph some horizontal or vertical lines here. Okay, so the first graph is y equals 3. So it's telling you the y value is 3. So if I were to write this as a point, I know what I need to do. Let me go here. Y equals mx plus b. Right? This is the equation we've been using. I'm just showing you. Okay, when they tell you y equals 3, or excuse me, negative 3, you can see here they're missing the slope. See how this is missing? So if I were to plug in what they said, I would just put the negative 3 here, and I'd have y equals mx plus b. You see that? Plus or minus 3. This is missing. You see that? That means that the m, or the slope, is 0. So it's like saying y equals 0x minus 3. Okay, if the slope is 0, you don't have to write this in there. And that's why you see that they just write y equals negative 3. Then when I graph this, my x value is 0, and my y value is negative 3. So I'm going to go down to negative 3, roughly down here, and put a dot. And then there's no slope. If you know that there's no slope, if you're on a hill and there's no slope to a hill, you're not on a hill, are you? You're on a flat piece of land. So I'm going to be, oh, I missed the dot. Make my dot bigger, and then I get the dot. Okay? So if there's no slope, think about it. If I'm skiing on a hill and snow skis and I come to no slope, am I going anywhere?
Yes.
Nope.
Yeah.
You're going to sit still. Question? Unless you're walking. Thank you.
So essentially, with these equations, we think of it as the y equals mx plus b, but then translate it to the other one, and if there is any missing part of it, we just assume that is 0?
Yep. Exactly. Exactamundo. Okay, so that's the first one. If I go back here and click, 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 you'll see it. Boom. Well, we did it, so I don't need to go through it slow.
There you do.
Definitely.
So your y value was at -3. I put a dot. The x value was 0, so I drew a horizontal line.
Well, I wasn't there for that.
Yes, you were.
I have no idea what you just
Okay, so let's do B. Okay, the x equals 2. New screen. X equals 2. Okay, so let's look at our equation. Y equals mx plus b. Do I have a plus b?
No.
No. So it's like saying y equals m2, because I have the x, plus 0. Okay? The slope is still going to be... this is not the right way to say this one. The y value is 0 here, this one. Nope. Yeah, this is not a good way to... I don't like this. Don't write that in your journal.
Too late.
Sorry. This is a confusing way to explain this. When x equals 2, okay, if you look at a coordinate, x is 2, the y value is 0. Okay, so if I were to plug this into my equation, this goes where the y is, this goes where the x is, right? X and y. So it'd be like 0 equals m times 2 plus b. Okay? In this case, there's no y-intercept. So if I were going to sketch this, that's a terrible coordinate. All I have to do is go on the x line to the positive 2. So 1, 2. Put a dot. And then it's a vertical line. Okay? Because if I know that x equals 2, then I know that m is 0.
Okay.
So there's no slope.
Yeah.
Technically, it's undefined slope. It's like saying 2 divided by 0.
Yeah.
It looks like a 6, but it's 2 divided by 0, which is undefined. Vertical lines can be a little tricky. So, when you see x equaling a number, you need to just recognize this is a vertical line at this value. So I went to 2, drew a vertical line. So if this was -2, I'd go back 2 and draw a vertical line here. All right, let's go. You see it?
Yeah.
Question?
Okay.
Vertical lines are a little harder to comprehend. But this is your key right here. If you have x equaling a number, it can be a fraction, it can be a decimal, it can be any of those. You just go on the x line to that point, put a point, and then draw a vertical line.
Okay.
All right. Go to your try it. Do you want me to look at it with you?
No, I think we got it. Under control.
I believe in you.
Yeah.
It's the
Okay.
same-
It's
the
what
same
we
thing
just
as-
did. It is what we just did.
No,
So, is this a horizontal or vertical line? Y equals 3.
I did.
vertical. Vertical.
See, this is where it gets tricky. You're on the Y line,
But you're
so you're going to go on the Y line and put it at 3, right? So what kind of line is this?
Vertical.
Horizontal.
Oh, okay.
You got to think backwards. So in order to make a line here, you just pick any other dot on this horizontal line. It does not matter as long as it's on the horizontal.
Oh, I did it.
Yeah.
Even though I don't know what's happened, I did it.
Okay? So let's look at the next one.
That was fun.
Is this going to be a horizontal or vertical line?
Yeah, one of them.
One of them is correct.
Horizontal.
Horizontal, because we're on the Y line again. So where are we going? Negative 1.5. So am I going up or down?
Down.
There's 1.5. Put a dot. Where do I put my second dot?
And wherever.
Anywhere on the horizontal line.
Wherever. Am I supposed to be saying this?
Yes.
Oh, this one's vertical.
Okay, so this is vertical. X equals negative 4. So starting at 0, do I go left or right? To the? Very good. And then it's a what kind of line? Vertical. We're all going to say it wrong after Aaron keeps saying it. So just anywhere on this vertical line, put another dot, and you got your vertical line.
Yay.
If you guys were to make a table like we were doing earlier to solve all these points, you would get these answers. But that's time consuming, so I'm trying to teach you the faster way to do this. Excellent. Excellent. Okay, last one, vertical or horizontal?
Vertical.
Vertical. So we're going to go on the X line, left or right?
Wait, no, right.
Is it positive or negative?
Positive.
Positive goes to the
Right.
right, so I'm going to go to the right half, put a dot, and it's a vertical, so I go anywhere on this. I'm going to go way up here and be crazy.
Okay, have fun.
Woo!
Oh, wait, I put it too much out.
All right, I'm doing your work for you today, guys.
Thank you. You're so sweet.
Oh, now you gotta do self-assess. That's all
Can
you.
you do that one with me?
Nope. I want y'all to try it. Self-assess. So do through number 12, and then we'll do our last example together.
Let me say this.
Okay, so which one are we doing together?
The
2?
second, yep.
Number dos. Okay, so what is my y-intercept?
I don't know, mine won't load.
Right here. Look up here.
Oh.
So I go down to the negative 2. See it drawn here? Negative 2, dot.
Yes, we did that part.
Okay, good. It's half the problem. What is my slope?
0.8.
0.8 over
1.
1. So from here, is it a positive or negative?
Positive.
So I'm going to go up 0.8. If you look at this, how much is 0.8? It's 2 lines, right?
Oh.
So from here, I'm going to go up 2
2.
and over 1.
Oh.
Should be like right there.
Oh. Wait. So, what? Wait. Okay.
No, it would be right there. Oh my word, that's a lot of lines. 2 up to 1. Should be there.
Up to, how much is 1?
That's incorrect.
Okay.
Okay.
So let's change. Okay, so let's do this differently. Go away. So we need to make this. Oh, duh, Carrie, brain fart. I apologize. No, make it a fraction. This is in decimal.
Didn't we just say?
Make it a fraction.
Oh.
How do you make this decimal a fraction? What place value is this?
8. Wait, no.
Tenth. So it'd be 8 over 10, right? Reduce 8 over 10. What do you get?
Like,
4 over 5?
yep. 4
So that's your slope. So we go down to 2, up 4 over 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So your slope is 4 over 5.
Oh, I did it, Misty.
Let me check it.
Whoa, how
Am I teaching you right? Yay. Sorry. Decimals, turn them into fractions. That's my bad. If you come up with a decimal, turn it into a fraction. And then reduce it, because you don't want giant fractions. Yep. 0.8 became 4/5. Number 3.
I couldn't explain it without my hands and eyes. Okay. Oh. So, on this one question that I'm on, it asks which one does it belong with.
Yeah.
All right, example 3. Put this in your journals.
Well, I can't write all that.
He threw right next to it.
Oh, yeah, that's right.
No, I'd rather.
All right, I'm back.
Oh, thank you.
The wind speed, represented by Y, in miles per hour of a tropical storm is represented here. What kind of equation is that? Ooh.
Simple.
A linear equation.
Linear equation. This forms a line where, shh, you guys are too loud, where X is the number of hours after the storm enters the Gulf of Mexico. When does the storm become a hurricane?
When the cold air and the hot air touches each other.
So this is where you have to solve for the other value. What does Y represent?
The wind speed.
Yeah, the wind speed. Very good. Which is in miles per hour. Under the picture here, are they telling you what the wind speed is? 74 miles per hour. So do you think we could plug that in where y is to solve for how long? Because what does x represent?
The number of hours.
number of hours.
The storm entered the Gulf of Mexico.
And they're asking us to solve for when it became a hurricane. So we're going to plug the 74 where the y is. So this is just solving for x. This is what 7th grade is doing right now. Ooh, don't do that. No. We're not going to do that. We're not going to... Hold on, let me click through this. Yuck.
Icky.
Don't do that. Don't do that. We're going to do it. Here. Boom. Easier way. Here we go. Okay, we have our equation. Y equals... Write this in your journals. 2x plus 66.
Yes.
Okay, we learned that the y value is our miles per hour, and we learned this storm was going 74. So we're going to plug that in where the y is. So we say 74. Stop throwing things.
Apologies.
2x plus 66. I hope you're writing this in your journals. There's not supposed to be a gap here. I just can't write with a mouse. All right, so now do we have one variable all by itself? Yes. Well, we need to make him all by himself. You are correct. So how do we get x by itself? What's the first thing we need to move? Right. Can we move the 2 first? No. Elena, what are we going to move first?
You subtract 66 by both sides.
Excellent. We're going to move the 66 first, so minus 66.
8.
So 8 equals 2x. Now how do we get the 2 away from the x? 7th grade is practicing this right now. So I have x equals... Okay, what does the x value represent again?
The number of hours after the storm entered the Gulf of Mexico.
So the answer is 4 hours. Now, if they asked you to graph this, you just take that and we graph it. 66 is my y-intercept. So I go up here, to 66 and put a dot. Oh, let me show you how they do that. Whenever it's a giant number like that, they go like this. They go, I don't want to draw all the way 66, so I'm going to break this graph here. They draw that little symbol, and then they make this 66, so it doesn't have to go so far. Okay, and then my slope is what?
2.
So I go up 2 over 1. 2, 3, 4. So then wherever it hits right here is at the 74. Because remember, we plugged in y for 74 here. So this point was 4, 74. You guys understand that?
Yeah.
So that would be this point right here. Okay? Hopefully they don't make you graph it. On word problems, they don't usually make you graph it. They just want this answer. How many hours? Like in this one, it doesn't say graph it. When does the storm become a hurricane?
It becomes a hurricane in 4 hours.
Correct. So that's when I'm grading it, that's all I would look for.
Okay.
Questions?
No questions.
Good?
Good.
Excellent. You have 3 more questions as homework.
Homework.
Yep, we're going to go to recess. Recess. Make sure you finish all the way through number 15 by tomorrow.